This is the prerequisite chapter in pre-calculus. We're going to look at lesson 1, and I'm only going to cover one topic that's in the lesson, interval notation, because you probably haven't seen that before because it's not in our other textbooks. But there is more in the chapter that you will be responsible for, so make sure you read the chapter or at least look at it before you attempt the problem, so you kind of review what you're going to be working on. And you're going to be working on sets of numbers, rational numbers, irrational numbers, working with exponents, powers, and a little bit of scientific notation. So make sure that you do that. But I'm only going to cover interval notation again because you may not have seen that before. Now, sorry, I just pushed that. Interval notation, when we're talking about an interval, we're just talking about a portion of a bigger set. So when we're looking at real numbers, we're looking at all numbers. You remember, real numbers are all the numbers that go all the way up into the positive direction forever and all the way down in the negative direction forever. That would represent all real numbers. Now, seldom are we looking at all of those numbers at once, and we're usually only looking at a part of that. Maybe the numbers between 0 and 10, or the numbers between -1 and 7. And that's just a fraction of, or a portion of, or an interval of the entire set. So that's where the name comes from, because we're only going to look at a portion of the entire set of real numbers. Now, there's three things that you may or may not have seen before, so three things we want to cover, and then we'll do a few examples. The first thing is, we said that real numbers go up forever, all the way into the positive direction, go up into what we call infinity. And we do have a mathematical symbol for infinity, and you may have seen this before, you may not, but the mathematical symbol for infinity looks something like that. It looks like an 8 laid down on its side. So you can make that however you want, as long as it looks fairly close to that. Some people do it like that. Some people, maybe if you do two circles, that looks like an 8, or however you want to do it, that's fine, but that would be the symbol that represents infinity. So we have all these numbers that go up to the right, the positive infinities, but we have all these numbers that go down to the left as well, these small numbers. So it's infinity, but it's down in the negative direction, so we put a negative sign in front of that to represent all those numbers to the left. So that's how you represent infinity. So that's the first thing new about interval notation. The next thing about interval notation is not new, but we're going to change the symbol of what you're used to. So before, in previous classes, you might have graphed the number -2, let's say, and let's say -2 was not included in your solution. We used an open circle. So hopefully you remember an open circle means that the number that you're talking about is not included in your answer set, whatever it is you're talking about. So an open circle means that it's not included. In interval notation, we're going to use something a little bit different. We're not going to use an open circle, but we're going to use a parentheses. So here's -2, it's not included, so I'm going to use a parentheses. Now, how do I know if the parenthesis goes to the right like this, or if it goes to the left? Well, that depends on if the rest of your problem is talking about numbers to the right, then you would open it to the right. Or if you're talking about numbers that are less than this, these numbers down here, you would go to the left. So the direction depends upon whether you want the person to look at the numbers to the left of that value or to the right. Okay, so we're going to use a parentheses, which means not included. Now, we also had another symbol for, let's say, the number 4, and let's say 4 was included. We used a closed circle. So a closed circle represented a number that was included in our answer set. Okay, so again, with interval notation, though, we're going to use a little bit different symbol. We're not going to use a closed circle. What we're going to use is a bracket. Okay, so instead of that, we're going to use a bracket. And again, whether I point the bracket to the right or to the left depends upon, am I going to be wanting the person to look at the numbers up here to the right or to the left? I want you to look at these numbers down here, so I'm going to make my bracket look down here. Okay, so those are the three things that may or may not have seen before that have to do with interval notation. Okay? Interval notation is going to take the place of inequality. So this inequality, this represents an inequality that I hope you recognize. We're looking at the x values that are greater than -2, but at the same time are less than or equal to 4. This is the graphical representation of this compound inequality. And as I said, interval notation is going to take the place of equality. So what you're going to do is this is going to go away. We're not going to use that. We are going to use these two numbers, and these are called the endpoints. Okay, and we're going to use the same symbol down here that we used up here. So -2, comma, to 4. This is talking about the numbers between -2 and 4, where -2 is not included, but 4 is included. So this is an interval from -2 up to 4. We're talking about the numbers between -2 and 4. This is a compound inequality, so the numbers that we're looking for are between these. Now when we're talking about an OR, where we have one going to the right and one going to the left, we'll talk about that in later lessons, but we're not going to tackle that in this lesson. Okay, so interval notation looks like this. So it takes the place of inequality. So let's do a couple of examples here, the types of examples you have to do in your book, and they'll give you an interval and ask you to write, they'll give you an inequality, ask you to write the equivalent in interval notation. So let's do one that we just kind of had. So from -7 less than x less than or equal to -2. So we're looking at the numbers between -7 and -2. What does that look like in interval notation? Sometimes it's easier to put it on the graph first, so let's do that. So -7 is not included, so not included, we use a parentheses, and we're looking at x is greater than that, so we're going to point this to the right. And then we have -2, and we're looking at the numbers less than that. -2 is included, so we put a bracket. So this would be the graphical representation. Okay, so then we can go ahead and put that in interval notation, where we're going from -7 up into -2. -7 is not included, -2 is included. So this would be the interval notation replacing the inequality. Right? Let me do one or two that have to do with infinity here, and let's say x is greater than 2. So where are the values x is greater than 2? What does it look like in interval notation? Well, we're looking at 2. We're looking at numbers that are greater than 2. 2 is not included, so we use the parentheses. Greater are the ones to the right, so my parentheses is going to go open to the right, and we're going to go up all the numbers greater than this. Well, where do they end? They never end, so they go all the way up into infinity because they never end. So how does that look in interval notation? Well, we do it the same way we do it with the other ones. We take this 2 all the way up to infinity. 2 is not included, and here's a little note. Whenever you have infinity, you must use a parentheses. Okay? You cannot close off infinity. You can't say it ends here, and basically that's what that symbol means. It ends here. Infinity goes on, it never ends, so it would make sense that we would never use this symbol. Okay? So that would be the interval notation for x is greater than 2. Let's take a look at one more that has to do with a less than. Let's say we're looking for all the x values that are less than or equal to -18. Okay, so again, a quick graphical picture. We're looking at -18. We're looking at the numbers that are less than or equal to, so it's a bracket. Less than numbers would be to the left, so my bracket's going to open to the left. And I'm looking at these numbers, and where do they end? Well, again, they go down forever, down into negative infinity. So this would be the graphical representation. The interval notation, again, is I take this number that's on the left first, which in this case has to be negative infinity. You can never bracket off infinity, so we use parentheses, up to including 18, so the same symbol that's here, I use this here. So this would be the interval notation. This would be the graphical representation of this inequality. Okay, so kind of 4 things just as a review real quick. Infinity symbol looks like this. The open symbol or an open circle is being replaced by a parentheses. The closed circle or included symbol is being taken place with a bracket. And remember, with infinity, you always have to use an open symbol when it's next to infinity. Okay? All right, check out video 2, talks about the types of intervals that we have, and that'll wrap up the lesson.